We like to believe that when we look into the night sky, we are seeing the universe itself. Stars scattered across darkness, galaxies floating like islands of light. A vast cosmic ocean revealed to us simply by opening our eyes or pointing a telescope upward. It feels complete. It feels whole. And yet, what we see is only a fragile illusion, a thin surface layer of something far larger, deeper, and mostly unreachable. Tonight, we are not asking what the universe is made of. We are asking something quieter and far more unsettling. How much of it do we actually see? Imagine standing on the shore of an infinite ocean at night. A narrow beam of light reaches a few meters into the water. Beneath that, darkness. You might describe the ocean based on what the light reveals. Waves, reflections, ripples. But the overwhelming majority of the ocean remains unseen, untouched, and unknown. This is not a limitation of curiosity. It is a limitation of light itself. The visible universe works the same way. Everything you have ever seen in astronomy, every galaxy image, every nebula, every deep field photograph, exists inside a small, carefully defined bubble. A region shaped not by space alone, but by time. Because in the universe, seeing something does not mean observing it as it is. It means receiving a message that has been traveling for millions or billions of years. Light is not instantaneous. Light has a speed, and that speed quietly defines the borders of everything we can ever observe. When you look at the moon, you see it as it was about 1 second ago. When you look at the sun, you see it as it was 8 minutes in the past. When you look at the nearest galaxy, Andromeda, you are seeing light that began its journey more than 2 million years ago, long before humans recorded history. And when we look deeper than that, we are not just looking far away, we are looking back in time. This means the universe does not reveal itself to us as a single moment. It reveals itself as a layered archive, a cosmic memory stretched across billions of years. The deeper we look, the younger the universe becomes. Galaxies shrink, structures dissolve, order gives way to chaos, and eventually, light itself begins to fade into something unrecognizable. But here is the crucial realization. There is a hard limit to how far back we can look. Not because our telescopes are weak, not because our technology is insufficient, but because the universe itself has placed a boundary between what can be seen and what forever remains beyond observation. This boundary is known as the observable universe. It is not the entire universe. It is not even close. It is the region from which light has had enough time to reach us since the beginning of cosmic expansion. A sphere centered on Earth, not because Earth is special, but because every observer occupies the center of their own observable horizon. Beyond this horizon, galaxies may exist in unimaginable numbers. Entire cosmic structures may stretch endlessly. Laws of physics may play out on scales we will never measure. But no signal from those regions has reached us yet, and some never will. So when we ask, what part of the universe do we see? We are really asking, what part of cosmic reality is allowed to communicate with us? The answer is surprisingly small. The observable universe has a radius of about 46 billion light-years. That number already feels enormous. But it hides a paradox. The universe is approximately 13.8 billion years old. How can we see objects farther away than 13.8 billion light-years? The answer lies in expansion. Space itself stretches while light is traveling through it. Galaxies move away, not because they are flying through space, but because space between us and them is expanding. The light that left them billions of years ago has been carried along by an ever-growing cosmic fabric. This means the observable universe is not a snapshot of distance. It is a snapshot of time. And even within this observable bubble, most of what exists is invisible. Stars, planets, gas, dust, everything that shines or reflects light, makes up less than 5% of the total cosmic content. The rest is something we do not see directly at all. Dark matter shapes galaxies without emitting light. Dark energy drives expansion without revealing its nature. Together, they dominate reality while remaining almost completely hidden. So already, within the part of the universe we can observe, most of it does not appear to us visually. And beyond that? Beyond the observable horizon lies a realm that may be hundreds, thousands, or infinitely many times larger than what we can see. A universe without edges, but with horizons. A reality that continues regardless of whether it can ever be observed. This realization changes something subtle inside us. It reminds us that human knowledge is not bounded by imagination, but by physics, by the speed of light, by the age of the cosmos, by the structure of space-time itself. And yet, within these limits, we have learned something extraordinary. By studying the faintest light, by measuring tiny distortions, by listening to ancient radiation left over from the birth of the universe, we have begun to map the visible edge of reality. For now, let your thoughts slow down. Imagine the sky above you, not as a window into everything, but as a delicate surface, a membrane of light separating what is known from what is still unreachable. We are floating inside a luminous bubble, and most of the universe lies quietly beyond it. At first glance, the universe seems generous with what it shows us. Even without instruments, the night sky reveals thousands of stars. With binoculars, we see clouds of light. With telescopes, entire galaxies appear, layered one behind another, stretching deep into space. It creates the impression that visibility is only a matter of power, that if we build bigger mirrors and more sensitive detectors, the universe will eventually reveal everything. But visibility in cosmology is not controlled by technology alone. It is controlled by time. Every observation you have ever made of the cosmos is an act of archaeology. Light does not arrive fresh from the present moment. It arrives aged, stretched, and altered by its journey. The farther it travels, the older it becomes. And this simple fact quietly reshapes everything we think we know about the size and structure of reality. Imagine freezing the universe at this exact moment. Somewhere, stars are exploding. Somewhere, galaxies are colliding. Somewhere, planets are forming around young suns. But none of that reaches us instantly. What we see tonight is not what exists tonight. It is what existed when the light began its journey toward us. This creates a strange situation. The universe has a present, but we can never observe it directly. The most distant galaxies we see today appear as they were billions of years ago, when the universe was young, smaller, and denser. Many of those galaxies no longer exist in that form. Some have merged. Some have changed beyond recognition. Some may have vanished entirely. Yet their ancient light continues to arrive, quietly telling stories from a time that no longer exists. This is why astronomers often say that looking deeper into space means looking further into the past. But this phrase hides something deeper. It means that the observable universe is not a complete object. It is a layered timeline compressed into a sphere around us. Closer objects represent recent chapters. Distant objects represent ancient ones. And beyond a certain point, there are no chapters left to read. This point is not arbitrary. It is set by the age of the universe itself. The universe began in a hot, dense state roughly 13.8 billion years ago. Before that moment, Space as we understand it did not exist. Time itself was not yet flowing in a way we can describe. Light could not travel freely. There was nothing to observe, not because nothing existed, but because the conditions required for observation had not yet formed. As the universe expanded and cooled, particles combined. Atoms formed. Space became transparent to light. This moment left behind a faint glow that still fills the cosmos today, the cosmic microwave background. It is the oldest light we can ever observe, and it marks the earliest visible boundary of the universe. No telescope, no matter how advanced, can see beyond it. Not because something blocks our view, but because there is no older light to collect. Beyond this boundary, the universe was opaque, dense, and filled with energy rather than structure. Information from that era does not travel to us in the form of light. It is locked away behind a curtain woven from physics itself. So when we speak about the observable universe, we are not speaking about distance alone. We are speaking about an information horizon, a limit defined by how long the universe has existed and how fast information can travel. This horizon surrounds us in all directions. Every observer, anywhere in the universe, carries their own observable bubble with them. From another galaxy, the observable universe would look similar in size, but centered on a different location. There is no privileged viewpoint, no universal center, just countless overlapping horizons, each defining what can and cannot be seen from that point in space-time. This realization quietly dissolves a common misconception that there is a single, shared picture of the universe. In reality, every location has its own version of cosmic visibility, shaped by its position and its moment in time. And yet, all of these bubbles are tiny compared to what may exist beyond them. Inflationary models suggest that the universe may extend far beyond the observable region, perhaps infinitely. If that is true, then what we see is not even a fraction of the whole. It is a local sample, a small illuminated patch inside a vast, unlit expanse. The thought is both humbling and strangely calming. It means that mystery is not a failure of science. It is a built-in feature of reality. The universe is not hiding from us out of hostility or indifference. It is simply larger than the speed at which information can travel. As you let this idea settle, imagine the observable universe not as a container, but as a softly glowing sphere drifting through something far greater. Inside it, galaxies shine, structures form, and time unfolds. Outside it, the same processes may be happening, silently, invisibly, and forever beyond our reach. And yet, even within this limitation, what we can see is enough to tell an extraordinary story. In the next movement, we will explore how expansion stretches this visible bubble, how galaxies slip beyond our horizon, and why parts of the universe that are visible today will one day disappear from view, not destroyed, but simply carried away by the growth of space itself. The boundary of what we can see is not fixed. It is alive, dynamic, and slowly changing with time. This may sound surprising, because we often imagine the observable universe as a stable sphere, once defined, forever the same. But in reality, visibility in the cosmos is shaped by expansion, and expansion never stops. Space itself is growing. This growth does not feel dramatic on human scales. Rooms do not stretch. Atoms do not drift apart. Gravity and other forces hold local structures together. But on the largest scales, between galaxies, between clusters, between vast cosmic voids, expansion quietly dominates everything. As space expands, galaxies move away from each other, not because they are accelerating through space like rockets, but because the space between them is stretching. The farther a galaxy is from us, the faster it recedes. At great enough distances, this recession becomes so rapid that light emitted today will never reach us, no matter how long we wait. This introduces a second, deeper horizon, not just a limit to what we can see now, but a limit to what we will ever see. Some galaxies that are visible today are already beyond this future horizon. Their light, emitted long ago, is still arriving. But any light they emit from this moment onward will be carried away by expansion, stretched and diluted, never crossing the growing gap between us. In a quiet sense, we are watching the universe slowly fade. Over cosmic time, distant galaxies slip out of view one by one. Their light becomes redder, weaker, stretched into wavelengths too long to detect. Eventually, they vanish entirely from observation. Not because they are destroyed, but because space has grown too large between us. This means the observable universe has a strange dual nature. In one sense, it grows. As time passes, light from slightly more distant regions has time to reach us. The observable bubble expands outward. We see more ancient light, more early structure, more of the universe's past. But in another sense, it shrinks. Because expansion accelerates. And acceleration means that more and more regions become permanently unreachable. The future observable universe will contain fewer galaxies than the present one. In the far future, observers may see only their local galaxy group, isolated in an otherwise dark and empty sky. This is not speculation. It is the natural consequence of dark energy. Dark energy acts like a quiet pressure embedded in space itself, causing expansion to speed up rather than slow down. Its presence ensures that cosmic isolation is inevitable. Over trillions of years, galaxies that are not gravitationally bound to us will disappear beyond the horizon of possibility. From their perspective, the same thing happens to us. This realization reframes what it means to ask how much of the universe we see. Visibility is not just limited, it is temporary. The cosmos grants access to certain information for a finite window of time, and then gently closes the door. And yet, within this fleeting window, we are extraordinarily lucky. We exist at an era when the universe is old enough for structure to have formed, but young enough that much of it is still visible. We can see galaxies billions of light years away. We can detect the faint echo of the Big Bang. We can map large-scale structure across immense distances. Future civilizations may not have this view. From their vantage point, the universe may appear small, static, and lonely. Without visible evidence of expansion, without distant galaxies to study, they may struggle to reconstruct the true cosmic story we take for granted today. This makes our current moment cosmologically special, not in space, but in time. We live during a brief epoch when the universe is readable. As you let this thought settle, imagine the observable universe as a living boundary, expanding in some directions, sealing itself in others. Light arrives from the deep past, even as future light quietly slips away, never to be seen. We are suspended between what is already spoken and what never will. In the next movement, we will explore what fills the observable universe. Not the stars and galaxies we see, but the invisible structures that dominate it. The unseen matter and energy that shape everything, while remaining almost completely hidden from our eyes. When we speak about what we see in the universe, it is tempting to focus on light. Stars burning, galaxies glowing, nebulae drifting like luminous clouds. Light feels like evidence. If something shines, it exists. If it does not, it feels absent. But the deepest truth of cosmology is this: most of what exists does not shine at all. The observable universe is dominated by what we cannot see. Every galaxy you have ever seen is embedded in an invisible structure, a vast, ghostly framework made of dark matter. A form of matter that does not emit, absorb, or reflect light. It does not glow. It does not cast shadows. And yet, without it, galaxies would not exist in their current form. Dark matter outweighs ordinary matter by a factor of about 5 to 1. It shapes the rotation of galaxies, binds clusters together, and carves the large-scale architecture of the cosmos. Galaxies are not scattered randomly through space. They trace long filaments, walls, and nodes, forming a cosmic web whose backbone is entirely invisible. When we look at a galaxy cluster through a telescope, we see bright islands of stars floating in darkness. But gravitational measurements reveal something astonishing. The visible matter accounts for only a small fraction of the cluster's total mass. The rest is dark matter, silently guiding motion, bending light, and holding everything together. In this sense, what we see is only the decorative surface of reality. Even more elusive is dark energy. Dark energy does not clump. It does not form structures. It does not gather into halos or filaments. Instead, it fills space itself, pushing the universe to expand faster and faster. It makes up roughly 70% of the total energy content of the cosmos. And yet, we have no direct image of it, no particle detection, no clear explanation of its nature. We know dark energy exists only because of its effect on what we can see. Galaxies move apart faster than expected. Expansion accelerates instead of slowing. Space behaves as if it contains a hidden pressure, quietly stretching everything from within. This unseen component dominates the future of the universe, while remaining almost entirely abstract to our senses. So when we ask what portion of the universe we see, the answer becomes even smaller. Within the observable universe, stars and galaxies, everything that emits light, make up less than 5% of reality. 95% is inferred indirectly, reconstructed through motion, gravity, and subtle distortions of light. This changes the meaning of observation itself. To observe the universe is not merely to look at it. It is to interpret its behavior, to read the bends in light caused by gravitational lensing, to measure the speeds of galaxies, to detect tiny fluctuations in ancient radiation. We see by understanding, not by sight alone. And even then, our picture remains incomplete. Between galaxies lie vast regions of near emptiness, cosmic voids spanning hundreds of millions of light years. These voids are not truly empty. They contain faint gas, dark matter, and quantum fields. But compared to the luminous knots of galaxies, they feel like silence between notes. Most of the observable volume of the universe is made of these voids. This means that even within what we can observe, most of space contains almost nothing visible at all. Matter is rare. Light is sparse. The universe is mostly quiet, dark, and thinly populated. And yet, this emptiness is not meaningless. The pattern of voids and filaments tells a story about the earliest moments after the Big Bang. Tiny fluctuations grew over billions of years, guided by gravity and expansion, shaping the cosmos into its present form. By mapping what we cannot see, we learn how everything we do see came to be. As you reflect on this, imagine drifting through the observable universe. You pass through enormous regions of darkness, punctuated by occasional islands of light. Around each island lies an unseen halo. Between them, an invisible force stretches space itself. The universe you see is not wrong, but it is radically incomplete. In the next movement, we will turn to the deepest boundary of visibility, the moment when the universe first became transparent to light. the ancient glow that marks the farthest edge of what observation allows, and the quiet limit beyond which light itself cannot carry information to us. There is a moment in the history of the universe when visibility truly begins. Before it, light could not travel freely. After it, the cosmos slowly opened its eyes. This moment marks the deepest boundary of what we can ever observe. Not because we lack the tools, but because the universe itself was once opaque. In the earliest times, the universe was not empty and transparent. It was hot, dense, and filled with a glowing plasma of charged particles. Electrons moved freely. Protons drifted without forming atoms. Photons, particles of light, scattered constantly, unable to travel more than tiny distances before colliding again. The universe was bright, but nothing could be seen. There were no stars, no galaxies, no structures at all. And even if there had been an observer, no image could form. Light was trapped, endlessly bouncing, carrying no clear information across space. As the universe expanded, it cooled. Slowly, over hundreds of thousands of years, conditions changed. Temperatures dropped enough for electrons to bind with protons, forming neutral atoms for the first time. When this happened, light was suddenly free. Photons that had been trapped since the beginning were released in all directions, beginning a journey that continues even now. This event is known as recombination, and the light released at that moment still fills the universe today as a faint, uniform glow. The cosmic microwave background. This ancient radiation is not dramatic to the eye. It does not paint the sky with color. It exists at microwave wavelengths, invisible to human senses. And yet, it is the most important image we will ever have of the early universe. It is the oldest light we can observe. When we map this radiation, we are not seeing stars or galaxies. We are seeing the universe as it was just 380,000 years after its beginning, long before any structure formed. Tiny fluctuations in temperature reveal the seeds of everything that would come later. Slightly denser regions would grow into galaxies and clusters. Slightly emptier regions would expand into vast cosmic voids. Beyond this surface, there is no light to collect. This does not mean there was nothing before recombination. It means that information from earlier times does not reach us in the form of images. The universe before transparency is hidden, not erased. In this sense, the cosmic microwave background is not a wall in space. It is a wall in time. No matter where we look, in any direction, we see this same ancient glow. It surrounds us completely, marking the farthest observable edge of the cosmos. Every observer, anywhere in the universe, would see a similar boundary. Their own version of this last scattering surface, centered on their location. This symmetry tells us something profound. The universe does not hide its beginnings behind distance alone. It hides them behind physics. There is simply no older light to receive, no clearer image to sharpen. The limit is absolute. And yet, even this limit speaks. By studying subtle patterns in this ancient radiation, we have learned about the age of the universe, its geometry, its composition, and its fate. We have inferred the presence of dark matter and dark energy. We have traced the imprint of primordial fluctuations that originated in the earliest moments of cosmic expansion. We cannot see beyond this boundary, but we can listen to its echoes. As you let this idea settle, imagine the observable universe as a sphere whose outer surface is not made of matter, but of ancient light, a quiet glow marking the moment when the cosmos first became visible. Everything closer is younger. Everything beyond is hidden in silence. In the next movement, we will step back and ask a deeper question. If we see only a fraction of space, a fraction of time, and a fraction of what exists, what does this mean for our understanding of reality itself and our place within it? When we accept how little of the universe we truly see, something subtle shifts in the way we think about reality. The cosmos stops being a completed picture and becomes a partial message, one that arrives fragmented, delayed, and filtered by the laws of physics themselves. What we call the universe is not the universe as it is now. It is the universe as it was. Every observation is a memory. Every image is an echo. Every spectrum is a relic of a moment that has already passed. This means that cosmology is not the study of a present reality, but of a deep and layered past, stitched together from photons that have survived immense journeys through expanding space. There is no single, universal now we can observe. Different regions of the observable universe appear frozen at different stages of cosmic history. Nearby space looks mature and structured. Distant space looks younger, rougher, less settled. The universe reveals itself to us not as a synchronized whole, but as a collage of eras. This has profound consequences for how we build models of reality. When scientists describe the size, age, or fate of the universe, they are not reading it directly. They are inferring it. They take incomplete data and search for patterns that remain consistent across time and distance. The success of cosmology lies not in perfect visibility, but in the surprising coherence of what little we can see. From a small observable patch, we infer universal laws. The same physics appears to govern distant galaxies as nearby ones. The same constants shape early radiation and modern stars. This consistency allows us to extend our understanding beyond direct observation, cautiously and mathematically, into regions we will never see. But this extension always carries humility with it. Because beyond the observable horizon, there is no guarantee that conditions remain identical. The universe may be uniform on large scales, or it may not. Inflationary theories suggest enormous regions beyond our view, potentially containing variations we will never measure. Entire cosmic domains may exist, forever causally disconnected from us. They are not hidden behind walls. They are hidden behind time. This reframes the question of meaning. If most of the universe is unobservable, does it matter? If realities exist that can never interact with us, do they belong to our description of nature? Physics answers quietly. Existence does not require observation. The cosmos does not wait to be seen. Our role is not to witness everything, but to understand what is possible. And within that understanding, limits are not failures. They are information. The existence of horizons tells us about the age of the universe, the speed of light, the structure of space-time, the presence of dark energy. Every boundary we encounter is itself a measurement. Even ignorance has shape. As you reflect on this, imagine knowledge not as a circle that eventually closes, but as a shoreline that grows longer the farther we explore. Each new discovery reveals more mystery beyond it. Each answer sharpens the outline of what remains unseen. This is not a reason for despair. It is a reason for wonder. Because within a universe that hides most of itself, a small, temporary window has opened. And within that window, we exist. We can ask questions. We can trace ancient light. We can reconstruct stories that began billions of years before we were born. In the next movement, we will gently explore a final, grounding idea. Given all these limits, how much of the universe do we truly need to see in order to understand our place within it? From inside the observable universe, it is easy to feel small. surrounded by distances measured in billions of light years, by forces that shape galaxies and epochs. The human presence can seem negligible. And yet, everything we understand about the cosmos emerges from this tiny vantage point. From within a single galaxy, around a single star, on a single planet. We do not stand outside the universe to observe it. We are inside it. This matters more than it seems, because the limits of what we can see are not just cosmic boundaries. They are also the conditions that make understanding possible. If the universe were fully visible, infinite, and instantaneous, it would overwhelm perception. There would be no structure, no narrative, no sequence. Meaning requires perspective, and perspective requires limits. The observable universe gives us exactly that. From this narrow window, we can reconstruct an immense story. We can trace the lives of stars. We can follow the evolution of galaxies. We can measure the expansion of space itself. We do not need to see everything to understand something fundamental. In fact, partial visibility is what allows patterns to emerge. Consider how we learn anything at all. We never experience a whole system in its entirety. We infer, we model, we test, we revise. The cosmos is no different. From a small sample of reality, governed by consistent laws, we extrapolate outward. And remarkably, it works. The same physical principles that operate in laboratories on Earth describe the behavior of distant quasars and ancient radiation. The same equations apply across billions of light years and billions of years of time. This coherence suggests that even the unseen parts of the universe are not arbitrary. They are connected to what we observe through shared structure and law. This does not remove mystery, but it gives it context. We are not excluded from the universe. We are participants within it. Our observations, though limited, are valid precisely because they arise from within the same reality we seek to understand. And this brings a quiet comfort. The fact that we cannot see beyond certain horizons does not diminish our place in the cosmos. It defines it. We exist at a moment when the universe is both old enough to be understood and young enough to be visible. A moment when light from the beginning still reaches us, and structure has matured enough to be studied. This balance will not last forever. In the far future, cosmic horizons will close. Evidence will fade. The sky will grow darker. But for now, the universe is open just enough for awareness to arise within it. As you let this idea settle, imagine the observable universe not as a cage, but as a cradle, a region of space-time where complexity, memory, and consciousness can emerge. A window wide enough for wonder, yet narrow enough for meaning. In the next movement, we will bring this journey toward a gentle synthesis, gathering everything we have explored into a single, quiet answer to the question we began with. How much of the universe do we truly see? And why is that enough? If we gather everything we have explored so far, a quiet pattern emerges. The universe does not present itself to us as a complete map. It speaks to us gradually, through signals that arrive with delay, distortion, and silence in between. What we call observation is not a survey of all that exists, but a dialogue between what can send information and what can receive it. The observable universe is not a container of reality. It is a conversation. Light travels. Space expands. Time passes. And within these conditions, certain messages reach us while others never will. This is not an accident or a flaw. It is the natural way a finite-speed universe communicates with itself. When we look into the sky, we are not reading a finished book. We are listening to a story still being told. One chapter at a time, with many pages missing and others permanently out of reach. The gaps do not break the narrative. They define it. Seeing little is not a limitation unique to humans. It is a property of the cosmos. Every observer, anywhere, at any time, will face horizons, boundaries where information fades, regions that exist without ever becoming observable. The universe is structured so that total visibility is impossible from within it. And yet, meaning does not require total access. From a small fraction of space and time, we have uncovered laws that apply universally. From faint radiation, we have reconstructed cosmic history. From tiny fluctuations, we have inferred vast, invisible structures. The dialogue works because reality is coherent, even when it is incomplete. This reframes our expectations. We do not need to see the whole universe to understand its nature. We need consistency, pattern, and patience. The cosmos offers these generously, even as it withholds most of itself. As you rest with this idea, imagine observation as listening in a quiet room. You do not hear every sound in the city. You hear what reaches you. And from that, you build a sense of the world beyond the walls. The universe works the same way. The observable region is not small because we are insignificant. It is small because reality is vast. And within this small region, awareness has emerged. Questions have formed. Curiosity has taken shape. The universe has become conscious of a tiny part of itself. In the next movement, we will gently turn toward the closing arc of this journey. Not by expanding outward, but by returning inward. By asking what it means, emotionally and philosophically, to live inside a universe where most of existence remains forever unseen. There is a quiet emotional response that emerges when we truly accept how little of the universe we can see. It is not fear, and it is not despair. It is something softer, a sense of calm humility, a recognition that reality is larger than our access to it, and that this has always been true. We live inside a mystery that does not demand resolution. Much of modern anxiety comes from the idea that everything must be known, measured, and controlled. But the cosmos does not operate this way. It allows knowledge to grow slowly, within boundaries, without ever becoming complete. In doing so, it invites a different relationship with understanding, one based on patience rather than dominance. To exist in a universe where most things are unseen is not a flaw of perception. It is the natural state of being alive. Our ancestors lived this way instinctively. They navigated oceans without seeing the far shore. They followed stars without knowing their distances. They trusted patterns long before explanations existed. In many ways, modern cosmology returns us to this ancient posture. Guided by faint signals, interpreting what arrives, accepting what does not. The observable universe becomes a teacher in this sense. It shows us that meaning does not require total exposure. Beauty does not require full illumination. Understanding does not require possession. Some truths are revealed only partially and remain powerful precisely because of that. When you look at the night sky knowing that most of it is hidden, the visible stars gain weight. Each point of light becomes rare. Each photon feels deliberate. The sky is no longer crowded, it is precious. This perspective softens the human role in the cosmos. We are not explorers conquering the unknown. We are listeners receiving what the universe is able to send. And in this listening, something profound happens. We become aligned with the tempo of reality itself. Slow, expansive, and indifferent to urgency. The universe does not rush to explain itself. It unfolds. As you breathe with this idea, imagine yourself floating gently inside the observable bubble. Light arrives from the deep past, touching your awareness briefly before passing on. Beyond the horizon, existence continues without needing to be witnessed. Nothing is missing. Nothing is incomplete. In the next movement, we will begin the final descent of this journey, bringing together science, perception, and quiet reflection into a closing understanding of what it truly means to see only a fraction of the universe, and why that fraction is enough. When we finally return to the question we began with, how much of the universe do we actually see? The answer becomes both precise and strangely calming. We see all that light has had time to show us. In terms of space, the observable universe forms a sphere with a radius of about 46 billion light-years. Inside it are hundreds of billions of galaxies, each containing hundreds of billions of stars. This sounds vast, and it is. But it is not the whole. If the universe extends far beyond this horizon, as current models strongly suggest, then the region we can observe may be only a tiny fraction of total existence. Possibly 1 part in thousands. Possibly far less. Possibly an infinitesimal sample of something effectively infinite. In terms of matter and energy, what we see directly is even smaller. Everything made of atoms, stars, planets, gas, dust, living beings, accounts for less than 5% of the cosmic content. Dark matter and dark energy dominate the observable universe while remaining unseen, inferred only through their influence. So the visible, luminous universe, the part that feels most real to our senses, is a thin layer resting on a much deeper foundation. And yet, this thin layer is not misleading. It carries enough information to reveal the universe's age, its expansion, its composition, and its history. From a limited view, we have reconstructed a remarkably consistent picture. The small fraction we see behaves as if it belongs to a much larger, coherent whole. This is the quiet miracle of cosmology. From little, we learn much. The numbers do not diminish us. They ground us. They remind us that understanding is not about total access, but about meaningful connection. The universe does not need to be fully visible to be intelligible. It needs only to be lawful, patient, and generous with the signals it sends. As you rest with these proportions, the seen and the unseen, imagine them not as a loss, but as a balance. Visibility gives us orientation. Invisibility gives us depth. Together, they create a cosmos that can be known without being exhausted. In the next and final movement, we will allow this understanding to settle fully, closing the circle of this journey and leaving the question not with a sharp answer, but with a quiet sense of place inside an immense, softly glowing mystery. It is tempting to imagine the universe as a vast object, something that exists all at once, fully formed, waiting to be observed, a cosmic structure frozen in its totality. But this image quietly misleads us. The universe is not a thing you can stand back from and view. It is a process unfolding through time. What we see is not space alone. It is space becoming. Every region of the observable universe represents a different stage in this process. Nearby space shows maturity and balance. Distant space shows youth and turbulence. The cosmic microwave background shows infancy. The universe reveals itself as a sequence, not a snapshot. This is why asking how much of the universe we see is inseparable from asking when we see it. Observation does not slice through reality horizontally. It cuts diagonally through space and time together. Each photon carries a timestamp. Each image is a moment preserved. When we assemble these moments, we do not reconstruct a static picture. We reconstruct motion. Expansion is not something that happened. It is something that is happening. Galaxies are not merely positioned in space. They are being carried by it. Distances are not fixed. Horizons are not walls. They are consequences of an evolving geometry that never pauses. In this sense, the observable universe is a moving window. It slides through the larger cosmos, continuously updating what can be known and what cannot. Some regions enter visibility as ancient light finally arrives. Others exit forever as expansion accelerates them beyond reach. Nothing about this process is personal. Nothing about it is hostile. It is simply how a universe with time behaves. Understanding this shifts our relationship with cosmic limits. Boundaries are not failures of perception. They are signatures of motion. They tell us that reality is alive, dynamic, and irreversibly unfolding. As you sit with this idea, imagine the universe not as a finished landscape, but as a slow breath. Inhale, space expands, horizons grow. Exhale, light fades, distances stretch. The rhythm continues without urgency. We do not stand at the edge of something static. We move within something becoming. In the next movement, we will follow this process forward into a distant future where visibility narrows, horizons close, and the universe grows quieter, not through destruction, but through distance. If we follow the observable universe forward in time, the story grows quieter, not through collapse or catastrophe, but through separation. Expansion continues. Distances increase. Horizons slowly tighten around what remains gravitationally bound. The night sky does not explode. It empties. Galaxies beyond our local group drift farther and farther away. Their light stretches, reddens, thins. Eventually, it fades beyond detectability. One by one, distant islands of stars slip out of view, not destroyed, not extinguished, simply carried beyond the reach of communication. In the far future, observers will see fewer galaxies than we do today, and eventually, perhaps only one. From that future perspective, the universe may appear static and small, without visible expansion, without distant markers, without evidence of a hotter, denser past. The great cosmic story will become harder to read, not because it never happened, but because its signals no longer arrive. This future silence is written into the same physics that allows us to see anything at all. Dark energy continues its quiet work, accelerating expansion and isolating regions of space-time from one another. The observable universe becomes more local, more intimate, more inward-looking. What remains visible is what remains connected. And yet, nothing essential is lost. The disappearance of distant galaxies does not erase their existence. It only ends the exchange of light. Reality continues beyond the horizon, just as it always has. The universe does not grow smaller. Our access to it narrows. As you sit with this idea, imagine visibility as a tide. It rises, revealing distant shores for a time. Then it slowly recedes, leaving behind familiar ground. The ocean does not vanish. The view simply changes. We live near the high tide of cosmic visibility. This does not make us privileged. It makes us temporary. In the next movement, we will turn to the final, quiet question beneath all of this. Why awareness, reflection, and meaning arise at all inside such a vast and mostly unseen universe? In a universe where most of reality is unseen, the emergence of awareness feels almost improbable. And yet, here it is, quietly asking questions, forming meanings, listening to ancient light. Consciousness does not arise in spite of cosmic limits. It arises within them. Awareness needs contrast. If everything were visible, immediate, and complete, there would be no mystery to orient toward, no uncertainty to explore, no distance to bridge. Curiosity would have no direction. Meaning would have no depth. The partial nature of the observable universe creates the conditions for reflection. We look because we cannot see it all. The human mind evolved not to comprehend infinity, but to navigate fragments, to recognize patterns in incomplete information, to infer wholes from pieces. In this sense, consciousness is perfectly adapted to a universe that reveals itself slowly and selectively. We are not anomalies. We are responses. The same laws that limit visibility also allow stability, memory, and complexity. Expansion creates time. Time allows structure. Structure allows life. And life allows questions to arise about the very process that made it possible. This loop is subtle and profound. The universe becomes aware of a small part of itself through beings who can only ever see a small part of it. There's no contradiction here. There is harmony. Observation does not need totality. It needs continuity and coherence. As you let this settle, imagine awareness as a gentle echo inside the observable bubble. Light arrives. Thought forms. Meaning emerges briefly. Then everything continues on its way. Nothing is forced. Nothing is central. And yet, something understands. This understanding does not conquer the universe. It resonates with it. We do not exist to see everything. We exist to witness something. In the final movement, we will allow this resonance to soften into stillness, returning one last time to the original question, not to answer it more precisely, but to rest within it. And so we return, gently, to where we began. To the night sky, to the quiet question, to the sense of looking outward and feeling something look back, not with intention, but with presence. How much of the universe do we see? We see what has arrived. We see what time has allowed. We see what distance has not yet carried away. A small fraction. A thin layer. A luminous surface floating inside something far greater. And this is enough. Enough to tell a story that began long before us. Enough to reveal patterns older than memory. Enough to remind us that reality does not need to be fully visible to be real. The unseen does not diminish the seen. It gives it depth. As the observable universe slowly breathes, expanding, aging, changing, light continues its quiet journey. Some of it reaches us. Most of it never will. Both are part of the same unfolding. Nothing is missing. Nothing is withheld. Nothing is incomplete. There is simply more than can be held at once. So let the question rest now, without tension. Let the horizon remain where it is. Let the darkness stay vast and patient. You are inside a universe that reveals itself slowly. And tonight, it has revealed just enough. Enough to wonder. Enough to listen. Enough to sleep. And beyond the edge of what can be seen, the universe continues, unchanged by observation, unhurried by understanding, quietly becoming itself.